Good morning, students. Today we discuss about crystal structure. Before going to crystal structure, first of all you are learn about some basic terms, especially for crystal structure. So, first term, particularly in crystal structure, the first term is crystallography. First term is crystallography. What is crystallography? So, according to this word converted into two words, one is crystal, second one is holography. So, crystallography, nothing but, especially it is the branch of physics. Crystallography is the branch of physics, otherwise it is the branch of science also. It is a branch of science. This physics is used to study the, particularly to study the structure and physical properties of the given structure, given crystal. So, crystallography is the branch of physics. This is used to study the structure and physical properties of the given structure. You can take any crystal. That crystal behavior and properties can be explained. Then that particular physics can be called as crystallography. Particularly our chapter is crystal structure. So our chapter name is crystal structure. So in this chapter you can explain about complete properties, structures, anything. Complete belongs to crystal. So this crystal behavior can be explained. Then that science can be called as crystallography. So it is very useful term, particularly in solid state physics, crystallography. In future, after completion of your MSc, you go to MPhil or PhD. Crystallography is the one of the paper in PhD level. So crystallography is used to study the properties. Particularly going to the PhD level, glass materials can be studied. That glass materials can be studied by using crystallography. So crystallography is also the one of the paper in future years, nothing but in PhD level. So this is the first word or first term is called as crystallography. Crystallography is the branch of physics which can study the structure and physical properties of given structure. So after that we are going to the crystal structure. Next term is, this is the first term, and the next term is lattice. Second term is lattice. So according to crystal, already we know about what is crystal. It is the periodic array of, it is the periodic array of arrangement of atoms, otherwise molecules, in a regular pattern. So crystal basic definition is periodical array of arrangement of atoms or molecules. So that is the definition of crystal. So here periodical array of atoms. So according to the lattice definition, in crystal structure there existing number of atoms are arranged like this, side by side. Like as I am taking 9 atoms. So I have arranged like this. So every atom has certain own mass. Every atom certain own mass. Nothing but m. This mass to be concentrated at a particular point. The position of the atom is indicated by like as dot. That position is represented in the crystal structure. That position of the point can be called as lattice. So in the crystal, the position of the all atoms is represented by using a point. That point is nothing but lattice. So crystal definition is the periodic array of arrangement of atoms or molecules. According to lattice, crystal can be defined as the periodic array of lattice points. Nothing but this entire structure is represented by using points like this. The periodical array of lattice points in a regular pattern. The total structure is called as crystal structure. So what is lattice? This is the point which is indicated by the position of the atom in the crystal. So that is the point. The point arrangement in a regular pattern, that complete structure is called as crystal structure. That is called as lattice. After completion of second word lattice, next learning word is space lattice. Next word is third one, space lattice. Each and everyone knows what is space. Space is nothing but three-dimensional point of view. We can take as a space. Nothing but you can explain anything in three-dimensional point of view. In three-dimensional point of view, what would you explain? Particularly, you explain the lattice. Lattice nothing but lattice points. The lattice points can be explained in terms of three-dimensional. Then the lattice point structure is called as space lattice. Nothing but you must explain every point in three-dimensional point of view. Nothing but this point can be explained with respect to x direction, with respect to y direction, with respect to z direction. So that point is expressed in terms of three-dimensional point of view. Then the total structure, nothing but crystal total structure with respect to three-dimensional point of view. The entire structure is called as space lattice. So that is lattice points are arranged in three-dimensional point of view. That is called as space lattice, simply called as, which is also simply called as crystal lattice. Space lattice, other name is called as crystal lattice. That is the third term. That is the third term. After completion of lattice and space lattice, we are going to next one is basis. Otherwise, which is also called as motif, which is term also known as motif. So what is basis? Suppose you can take one crystal structure. Suppose I am taking crystals like this. I am arranging the atoms. Bigger atoms I am taking totally 9. With the surroundings, some small atoms are existed like this. So in this crystal structure there are existing two types of atoms. One is bigger atom, another one is small atom. Entire crystal structure is repeated by using very small quantity of atoms in every crystal structure. The crystal structure consisting of two atoms. One is bigger atom, another one is small atom. That combination of repeated atoms to give the complete crystal structure. That smallest portion or smallest number of atoms combination can be called as basis. Can be called as basis. Suppose you can take as best example diamond. Diamond structure is layer structure. Particularly the structure of diamond is layer. Otherwise, which is also in chain form. This diamond structure existing only carbon atoms. Only carbon atoms. The carbon atoms are structure can be taken as carbon existing 4 bonds. This bond is bonded with next carbon. This is bonded with next, like this. So in this diamond structure, the complete layer structure is repeated with carbon. This single carbon atom can be called as in crystal structure basis. The smallest atom or molecules which are repeated gives the entire crystal structure. The smallest number of atoms or molecule combination can be called as basis, otherwise motif. That is the fourth basic term. The next basic term is crystal structure. Already known, crystal is nothing but combination of periodic array of atoms or molecules in a regular pattern. So in crystal I am taking like this. So in this crystal, some big atoms and small atom combination is existed. This is the crystal structure. So in this crystal there are existing bigger atoms and smaller atoms. According to the crystal structure mainly explained on the basis of lattice. What is lattice or lattice point? Lattice or lattice point is nothing but the entire atom or molecule is to be concentrated at a particular position. That position indicating point can be called as lattice. Suppose this entire combination can be taken as, in previous word, this is called as basis. So this basis term is repeated, total crystal structure is existed. So this basis total is concentrated at a particular point, that is called as lattice point. Suppose this is lattice point, this one lattice point, this one lattice point. So in this crystal structure, what are there? Basis is there and lattice point is there. So I am taking entire crystal structure consisting of crystal structure consisting of basis plus lattice point. This total combination can be called as crystal structure. So every crystal structure consisting of one basis and lattice point. This complete basis and lattice points are repeated, they give the entire structure. Simply it is called as the combination of basis and space lattice. Space lattice. Space lattice is nothing but we can explain in three-dimensional point of view. That entire structure is called as crystal structure. So this is basis and lattice point combination can be called as crystal structure. That is called as crystal structure. After completion of crystal structure, and next one is lattice plane. Lattice plane. So what are lattice? Lattice are nothing but atoms representing point. So I am taking the crystal. First of all, I am taking one of the crystal structure. This crystal structure with respect to I am taking lattice point. So regular or periodical arrangement of lattice points can be called as crystal structure. So here I am taking the crystal structure consisting of 14 lattice points. With respect to, I am explaining, with respect to lattice point, you can explain the lattice plane. Plane, the line or plane passing through lattice point. So the plane passing through the lattice point can be called as lattice plane. Suppose in this structure, I am taking lattice plane. So horizontal number 4 lattice points are there. I am passing one plane like this. This is one lattice, second lattice plane, third lattice plane and fourth lattice plane. So according to I am drawing the lattice plane with respect to lattice point in horizontal manner. So this is the reason to draw the lattice plane in horizontal way. So there is no particular way. You can draw the lattice planes in vertical way also, like this. There is no rule for drawing the lattice plane horizontal, vertical, there is no need. So the plane must passing through the lattice points, then the plane can be called as lattice plane. So these are the vertical lattice planes, these are the horizontal lattice plane. So one more. Like this. These are also the lattice planes. So lattice planes are nothing but the plane must passing through the lattice points. So in that lattice point there existing on that plane there existing lattice point. Those are called as lattice planes. So lattice planes you can draw like this. You can go anywhere. That is lattice plane. And next term is seventh one, unit cell. Unit is nothing but, according to numerical point of view, this value is equal to 1 meter with respect to length, with respect to area 1 meter square, with respect to volume 1 meter cube, according to numerical point of view. In this crystal structure, unit is nothing but same. Unit is nothing but same. Unit cell. So what is unit cell in crystal structure? In crystal structure, suppose you have the one structure like this. In this structure, you can take one smallest element. This is the smallest element. This smallest element consisting of minimum number of atoms or molecules, minimum number of atoms or molecules which are repeated, to give the entire crystal structure. This smallest portion we are repeated in left, right, upward, bottom, anything. The entire crystal structure is repeated by using this smallest cell. This smallest cell can be called as unit cell. So that is the minimum, which consisting of minimum number of atoms or molecule. That is called as a unit cell. It may be taken at corner or midpoint, at any point, any position of the crystal. You can take any position of the crystal, the smallest portion which is repeated to give the entire crystal structure. Then that crystal can be called as, smallest crystal can be called as unit cell, their existing number. After completion of unit cell, we are going to the next definition is primitive cell. Primitive cell is nothing but, first of all, it is a unit cell. Primitive cell is nothing but, first of all, a unit cell. What is unit cell? Unit cell is nothing but smallest element in the entire crystal structure which is repeated to give the total structure. So in a similar way, primitive cell is nothing but unit cell, first of all. So nothing but, which is the smallest element. But it consisting of lattice points, at its corners. Suppose you are taking one unit cell like this. In this unit cell, corners at here, I am drawing the one square structure. In this square structure there are existing four corners. I am not representing any lattice point at the corner. So suppose this structure is repeated to give the entire crystal structure, then the crystal, this smallest crystal can be called as unit cell. Particularly at every four corners lattice points are existed, then this unit cell can be called as primitive cell. In the unit cell there existing the corners, lattice points are existed or not, anything. Suppose here one unit cell is constructed. I am taking The lattice point is existed exactly midpoint. This crystal, this unit cell is repeated, total structure is given, then the cell is called as unit cell. Suppose I am taking one more unit cell. This is the unit cell. The lattice points are existed at its corner like this. This structure is repeated to give the entire structure. This cell is called as unit cell. So in the unit cell, the lattice points are existed at its corner or center at any way. So that entire structure is repeated to give the total structure. Then the smallest cell is called as unit cell. Particularly, you have the unit cell. That unit cell corners are occupied by lattice points. These lattice points are repeated to give the complete structure. Then the smallest unit cell can be called as primitive cell. In a simple way, every unit cell having the corners lattice point, that every unit cell can be called as primitive cell. So primitive cell consisting of lattice point at its corners only, that is called as a primitive cell. And next basic term, lattice parameters or unit cell parameters. Lattice or unit cell parameters. So lattice or crystal can be explained in three-dimensional point of view. Lattice is nothing but actually space lattice. Space lattice is nothing but the crystal must be expressed in terms of three-dimensional point of view. Suppose you can take one cubic structure like this. This cube can be explained in terms of three-dimensional point of view. So I am taking this intersect point can be taken as origin O. From this origin, this can be taken as x direction, this can be taken as y direction, this can be taken as z direction. So this entire structure can be explained in terms of three-dimensional point of view, x, y and z. This x axis, y axis and z axis. Axis is nothing but particularly they give the directions. These directions can be called as crystallographic axis. These x, y, z directions can be called as crystallographic axes. That is called as representation the directions in three-dimensional point of view. So according to the three-dimensional point of view, you are taking one crystal which is in a cubic structure. Suppose from origin to on x-axis, the cutting intercept nothing but this point. So from origin to cutting intercept, this intercept value can be taken as A. In a similar fashion, along y direction, this is the intercept. From origin to this intersect point, the length can be taken as B. From z direction, this is. From origin to this direction can be taken as C. So here the intercepts A, B, C are called as primitives. Those are called as primitives. The intercepts of x, y, z and are called as primitives. Otherwise, those are also called as characteristic. Those are called as characteristic intercepts. So A, B, C are called as intercept along x direction, y direction and z direction. Those are called as primitives. Otherwise, those are called as characteristic intercepts. Otherwise, those are also called as fundamental translator vectors. Those are also called as fundamental translational vectors. Anything you can say. Primitives are characteristic intercepts or fundamental translation vectors. Otherwise those are also called as axial length. Axial length. So A, B, C are called as primitives. So according to the three-dimensional point of view, I am taking angles also. Those are called as crystallographic angles. That angles from Y to Z, nothing but the angle between intercepts B and C can be taken as alpha. The angle between B and C is called as alpha, and C and A, C and A can be called as beta. C and A can be called as beta, and remaining A and B, A and B can be taken as gamma. So these alpha, beta, gamma can be called as crystallographic angles. So entire the crystal structure can be explained in three-dimensional point of view. In this three-dimensional point of view, in this structure you have totally 6 parameters are existed. With respect to axial length, 3 parameters A, B, C are there. With respect to crystallographic angles, alpha, beta, gamma are there. So these 6 are called as A, B, C and alpha, beta, gamma. These 6 are called as parameters. Parameters to explain total crystal or total crystal structure. So you can explain the crystal structure. You must need minimum 6 lattice parameters. Those lattice parameters with respect to axial length are 3. Those are A, B, C. A, B, C are the intercepts along x-axis, y-axis and z-axis, and alpha, beta, gamma are called as axial crystallographic angles. In between y and z angle is in between y and z angle is alpha, z and x axis is beta, and x and y is gamma. These 6 are called as lattice parameters. Based on these 6 lattice parameters, we can clearly explain the crystal structure in three-dimensional point of view. That is called as very important. Those are called as lattice parameters. In this, any crystal can be explained on based on these lattice parameters. Those are A, B, C and alpha, beta, gamma. Those are called as parameters to explain the crystal structure.